So in this unit, Unit H, we're going to start talking about polynomials and quadratic functions. It will be our third type of function that we're going to look at this year, and our last type of function. We'll go more in depth with quadratics next unit, but this is kind of going to be a unit that introduces it and gives us a good background of what quadratics will look like. Okay, so first thing we're going to look at here are a couple different names of polynomials and how to name polynomials in this lesson. So a monomial, meaning that it has just one term. Okay, mono meaning one. So a number could be a term, a variable could be a term, any set of numbers and variables could be a term. Okay, the only way that a term is counted as two terms is if you look here in G plus 9, okay, now there's multiple terms. It's separated by an addition or subtraction sign. So until you see addition or subtraction sign, it counts as just one term. So that's why all of these are monomials, one term. Okay, in this polynomial, meaning multiple, okay, there are three different terms. Okay, 3m squared is one term, negative 2m is another term, and 7 is the third term. Okay, separated by addition and subtraction signs. Okay, so talking about the degree of a polynomial or a monomial, when you're talking about the degree of a monomial, you add all of the exponents. So that's going to be the sum of the exponents. Okay. The degree of a polynomial is the highest degree in any monomial inside of that polynomial. Okay, so if you look at this first one, this is a polynomial, okay, because it has three terms. Here's one term, two terms, three terms. Okay, and so since it's a polynomial, you look for the highest degree of any monomial inside of it. So the degree of this first monomial would be 3. The degree of the second monomial is going to be 7. If you add the 3 and the 4, you add the exponents in monomials. And the degree here is 0 because exponents of variables. I should make sure that's important too. It's exponents of variables, not exponents of any numbers. Okay, so this one would be a degree of 7. Here it's a degree of 1 because it's a polynomial. It's got two terms. Okay, 3x is the first term, negative 2 is the second term, and the degree of the first term is 1. It has an exponent, and the exponents are. It has a variable, and the variable's exponent is 1. So that degree is 1, this degree is 0. So the degree of the whole polynomial is the highest monomial, which is right here, it's 1. This would be a monomial, and its degree is 0 because it doesn't have a variable. So I look for exponents of variables. Since there's no variable, it's just 0. Okay? Down here, another polynomial. Okay, we have x squared, negative 3x, and 2. So we find, since it's a polynomial, the highest degree monomial inside of there, and that highest degree monomial is 2. So our answer for the degree of this polynomial is going to be 2. Okay? Here we have a monomial. There's only one term. There's no addition or subtraction signs. So now I add the exponents of the variables up to get my total degree. 1 and 1 gives us a degree of 2. Okay, again, another polynomial, and you have to be careful on this one. Okay, there's 3 terms. The degree for the first term is 2. The degree for the second term, remember you add the exponents of variables, we get 4. And the degree of the last term is 1. So the highest degree is 4, so the degree of the polynomial is 4. Okay. This is important when we write in standard form. Okay, standard form is highest degree to lowest degree, left to right. Okay, so an example would be if I have like x squared plus x cubed minus 4x. Okay, standard form would say to write the x cubed first because highest degree, so it would be x cubed plus x squared, and then minus 4x. Okay, so notice how as I go left to right, the degrees are getting smaller, and that's standard form. Okay, and that's the way we're going to normally write them. Okay, adding and subtracting polynomials. When you're adding polynomials, you're adding like terms. That's basically it. It's simplifying and adding like terms. We've done this a lot in the past. It's just going to get to be a little bit more this time. So if you look at the first one, okay, we have negative 7x squared minus 180x plus 5,800 plus the 20 of 21x squared minus 140x plus 1,900. So like terms across the whole way would be negative 7.1x squared and 21x squared. You would add them together, so it's basically like 21 minus 7.1 gives us 13.9. X squared. So when you're adding like terms, you're only adding the coefficients. That's the number in front of the variable. You just leave the variables and the exponents as they are. Okay. Now we combine our x's, so we have negative 180x and negative 140x, which is going to give us negative 320x. And then the last pair of like terms is the 5800 and the 1900. In order, and this I should have said this already or earlier, but in order to be like terms, they have to have the same variable and same exponent. Okay, so that's why x squared are like terms, x are like terms, and now just constants or just numbers are always like terms too. So when we add 5800 and 1900 together, we're going to get 17, or not 17, sorry. We are going to get 7,700. Okay. Notice I wrote everything from highest degree to lowest degree. Okay. Make sure we always do that, highest degree to lowest degree. The next one, okay, now I'm going to combine like terms again. You could add vertically like they said here, or you can add using the arrows. I always like to connect them with arrows. So I'm going to connect 3m squared and negative 2m squared, and that's going to give me just 1m squared. Okay, there's no m. The only m I have is negative 5m, so I'm just going to write that. Always go with highest degree or lowest degree, standard form. And then 14 and 8 is going to leave us with 22. Okay. Again, standard form, highest degree to lowest degree. Okay, when we subtract, here's what I always like to say about subtracting polynomials. Because it's negative, you're subtracting this whole thing. I like to distribute the negative to everything inside and then rewrite it with an addition sign. So everything in the first set of parentheses stays the same. The next set, all is going to become opposite. So I'm going to say plus instead of the negative because I'm going to distribute the negative. So now I'm going to say plus negative 7x cubed minus 5x squared plus 12. Because we always want to make sure we distribute that to everything, and it really just means opposite of what it was before. So now I can combine like terms. I have x cubed and negative 7x cubed. So that's going to leave me with negative 6. X cubed. Okay. And then I have negative 3x squared and negative 5x squared is going to give us negative 8x squared. And then I have just 5x. That's the only x term I have. So we say plus 5x. And then the last thing I have is this plus 12 down here. Okay. So just make sure you change everything to opposite. So we'll do the same thing on this one. Distribute the negative to 3g and the 5. So now I'm going to rewrite it as plus negative 3g minus 5. Okay, and I don't need this anymore because I rewrote it down here. So now, like terms, I have g squared, my only squared term. And then I have negative 3g, it's my only g term. And then I have negative 2 and negative 5 to give me negative 7. Okay? So when adding and subtracting, you're just basically adding like terms. Okay? And like terms are terms that have the same variable and same exponent. Okay, make sure we're going to be naming these, okay? So make sure you know how to name. Okay, this would be a good table to make sure you know where it is at. Okay, always name by degree and then term. So 0, if it's got a degree of 0, it's a constant. And if it has a term of 1, it's a monomial. So this 6 is a constant monomial, would be the name. Okay, but it has a degree of 1. So if you look at this polynomial, the highest degree is 1. It's linear. And it has 2 terms, so it's a binomial. Bi meaning 2. Linear, this is our linear functions that we did earlier, the 5x plus 9. Okay, that's slope-intercept form. So that would be a linear binomial. If it has a degree of 2, which we're going to be working a lot with now coming up, okay, it's a quadratic. And since it has 3 terms, it's a trinomial. Okay, so a quadratic trinomial. A term or a degree of 3 is cubic, and it's a monomial because it has just 1 term. So it's a cubic monomial. And then anything over 3 is not going to have a special name for degree. It's just going to be 4th degree, 5th degree, 6th degree, and so on. Okay, and that's what I have down here in blue. Okay, 4th degree and higher polynomials, they do have special names, but they're usually just called the 5th degree, 6th degree, 7th degree. So once we get beyond a degree of 3, we'll just call them 4th, 5th, 6th, and so on. Okay. Same thing with naming by term. You name by term, you have 1, 2, and 3, monomial, binomial, trinomial. After that, so when we have 4 terms or more, so I'm going to say 4 plus terms. then it's just called a polynomial, because it means multiple. Okay? So if it has 4 or more terms, it's a polynomial. So let's practice naming these. We have 3x plus 4x squared. Okay, name it by degree. Since it's got a highest degree of 2, that's going to be a quadratic. Okay, and then there's 2 terms. Remember, terms are separated by addition or subtraction signs, so it's a binomial. Okay. Next one, we could combine some like terms here. So we're going to add the 4h and the 7h, and we get 11h minus 1 plus 5h cubed. So named by a degree, the highest degree is a 3. So then we're going to call it cubic. And there's 3 terms, trinomial. Next one, no like terms to add. So I just find the highest degree. Highest degree here is 2. So it's quadratic again. And it's got 3 terms, trinomial. Always degree and then number of terms. And then the last one, you can add those together because they both have like terms, y to the 4th and y to the 4th. So I add 7 and 3 together to get 10 y to the 4th. Okay, so now the degree of a monomial, because I know it's a monomial because there's only one term, so we could put that down. A monomial. And the degree of the monomial, you add exponents of all variables. Since there's only one variable, that's easy to add, so we call that a 4th degree. Remember, once it gets above 3, there's no special name for it anymore. So it's a 4th degree monomial. Okay, and then what I'd like you to do, see if you can come up with your own linear binomial, your own cubic monomial, your own 5th degree binomial. Okay. So finish those 3, and then I'll check your notes tomorrow, and we'll go from there. Have a good night.